In this video, we're going to be doing Cambridge Year 12 Extension 1 Exercise 8D, question 8. In the diagram to the right here, which does have a lot of annotations, A, D, and B are altitudes of triangle ABC. So this is the altitude, which means it's perpendicular to each other, as well as BE being an altitude there. So the intersector at P, which is over here. Let A, B, C, and P be the respective position vectors of A, B, C, and P relative to origin O. So what I did was I just stuck an origin somewhere and I just drew vectors to those letters that they said there. Okay, and I just called them the vectors A, C, P, and B. Then explain why P minus A dot product C minus B is equal to 0. Well, the thing is, if you have P minus A, right? Okay, well, P is over here, okay? But minus A will be the vector going this way. So the resultant vector would be this one here, okay? So that's basically AP. So this is basically AP. So if you just follow what I wrote here, might be easier, okay? So P minus A is the same thing as AP. C minus B, however, if I just point this out, C is this way, and minus B is going this way. Okay, it's opposite to B. So that means the resultant vector is going to be this, which is BC. Okay, so C minus B is BC. Okay, or you can follow this way as well if you wanted to. Then, because we are doing basically the dot product of AP, okay, and BC, according to this, these are actually perpendicular because since AD is perpendicular to BC, which is what I wrote here, and P is a point that lies on this line here, okay, between A and D, that means AP should also be perpendicular to BC as well. Okay? Right. The other thing I would also note that is that if you want to do a quick way of doing this, P minus A, provided these are position vectors, it's just the vector that starts from A and points towards P. So that's just this one here. Okay, provided A and P are position vectors. So if you have a look at this one here on question B, P minus B. So that means start from B and point to P. So start from B, point to P, that's this. Okay, so that means vector P minus B is equal to BP. A minus C means from C, go to A. So C was, let me just double check, C is over here. Okay, so C is this one. But from C, just go to A. So that's this. Okay, so that means A minus C is CA. Okay, but then again, looking at BP, which is this, and CA, and we're just finding the dot product of those. Well, those are 90 degrees to each other because, again, B is perpendicular to CA, okay, over here, but then P is just a point that lies in between B to E. So if BE is perpendicular to CA, then PB is also perpendicular to CA as well. Okay, hence why this is equal to 0. And this is just an alternate way of writing it out if you wanted to know. Okay. As for part C, we'll hence show that P minus C and A minus B dot product to give you 0. Okay. This one's rather hard. So how you would do this one is you would expand it out. Okay. So if you expand, let's have a look. So P dot C, okay, which is this up at top. So P dot C and P dot B. Let me just grab this down so you can see that actually. Okay, this is from part A. Okay, so you can see that if I do that dot product, that, and that, okay, if you expand that, they'll give you this result over here. Okay. Whereas if I then expand this one here from part B, okay, if I do this, 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 and this, okay, that will give this result here as well. Okay, so the thing is, if you now have these two out, okay, we're about to do something to them, but let's also expand this one. Okay, let's just say we didn't know that we had to do that. Well, if we expand this, p dot a, p dot minus b minus c dot a, and plus c dot b, that gives us this result here. Okay, so let's just say we did this, and we did this part. Okay, and we didn't know it's equal to 0 yet. Well, you want p dot a to stay. Okay, so you want this to stay, but you want this to go. Okay, you don't see any p dot c's anywhere here. So to eliminate them, you would have to add this equation with that equation, provided that's like one's plus and one's minus. So then you would have to add both equations. So add these two equations together. So these cancel, as you can see. And what's left here is just these terms here. So p dot a minus p dot b minus a dot c plus b dot c, which is this. Okay, and we know that this is equal to 0 because the previous two equations that we got it from were equal to 0. So if you add the right sides together, it does actually equal to 0 and 0. Yeah. Okay. So then that means your original question, which is this, which is in expanded form is this, that's now equal to 0 as well. Okay. So I would say that these first 2 or 3 questions are likely to be maybe tested in HSC, okay? But the last one, I would be hesitant to say that it won't be, okay, actually. I think it's rare, I think it's a rare case that it will be in the HSC. So, I think that's more for you to read by yourself. Okay, I'll leave that to you.